All right, folks. So we've got a problem where I'm dealing with. This is Mr. Dell. We are looking at a problem that has to do with ratios and proportions to determine missing values. So this is a problem from CPM's course 3. This is section 6.1.4 and specifically number 6-40. So it says Angel is picking mountain blueberries for a delicious pie. It says she can pick 1/6 cup of blueberries in 2 minutes. If she needs 2.5 cups of blueberries for the pie, how long will it take her to pick the berries? So right here, I have a ratio. Remember, ratios are our friends because basically a ratio is a fraction. It's a something we can. It's a comparison of two things, right? In this case, it's a rate. Ratios are also rates, right? So my ratio that I'm going to create is 1/6 cup, okay, in 2 minutes. And I know I have a fraction and a fraction, and that's okay when I'm writing a ratio at first, because then I can use the rules of fraction to change it and get a different fraction, right? So 1/6 cup in 2 minutes. So there's my ratio. So it's a big fraction, 1/6 cup over 2 minutes. Okay. So it says, though, she needs 2.5 cups. And we want to know how much time, oops, that should be a question mark. How much time will that take? So I have another ratio. I have a ratio that has two knowns, my 1/6 cup over 2 minutes, and another ratio that says 2.5 cups over my question mark, my unknown. So that's why I wrote this, because I want you to see I can take this fraction and manipulate it to make it to where I can get that answer there. So what we'll do is I want to know how many minutes it takes. So I'm gonna rewrite this as a um, as a as a fraction without the units. So what I have is 1/6 over 2, and I want that to be equal to 2.5 over x, because that's what I'm trying to figure out. So I have 1/6 over 2 equals 2.5 over x. So I have to solve for x. I basically have this equation that I have to solve for x. So there's a few ways to do this. There's something called cross multiplication, and that's a nice little trick to do and to solve. But I want to show you a way that makes a little bit more sense to me. Cross multiplication is um, a, a tool you have to memorize and know when to use it and how to use it. So in this case, I know that any fraction, right? I'm going to take a little side note over here. Any fraction, if it was 2/3 is equal to 4/6, right? We know that that's to be true, right? 2 over 3 is 4 over 6. Why? Because if I multiply top and bottom by 2, they're the same thing. And if I take those two fractions and I flip them, 3 over 2, does it equal 6 over 4? Is that the same thing? Do they still equal each other? Yeah, because again, I could still multiply top and bottom by 2 and I still get 6 over 4, right? So this is true. So basically what I was trying to show you is I could take both fractions and do the reciprocal, flip them over, and they still would be equal. And I'm doing that because I'm going to do that to this one, because what I want to do is I want to get my x on top. So 2 over 1/6 is the same thing as x over 2.5. I basically took those two fractions and flipped them. And I did that because I'm trying to get my x and I want to solve for x. Well, I'm there because what I have is I have x divided by 2.5. And when you're trying to isolate x on a equation, you're trying to solve for x and get x alone. You're basically, I'm going to cover this up so I can have more space to work. You're looking to what operation can I do to get x by itself, right? I'm looking to get my x alone. So what I would do is I can do the inverse operation. If x is being divided by 2.5, that means I can multiply by 2.5, right? Inverse operations cancel each other out, right? Positives and negatives cancel each other out. They're inverse. They're opposites. The opposite of division is multiplication. So if you are wanting to do the opposite, opposites cancel. So that gives me my x alone. So to do this right, though, what do you do to one side? I have to do the other. I have to multiply by 2.5. Now, that looks ugly, but don't worry. We'll work through this. So what I have here is I have 2.5. Let me line that back up. 2.5 over 1, right? Times, because I can put anything over run, 2 over 1/6. So now I just multiply straight across. I'm just dealing with rules of fractions. I know they're fractions within fractions, but you're dealing with the rules of fractions. So 2.5 times 2, well, 2.5 times 2 is 5, right? If I take 2.5, $2.50, and I double it, 2.5 doubled is 5. So this becomes now 5 over 1 over 6. And when you have a fraction, that over also means division. So what this really means is, this means 5 divided by 1/6, right? And then division of a fraction is the same thing as multiplying by the reciprocal. So 5 divided by 1/6 is 5 times 6, which is really 30. So that's, I know there's a lot of manipulation of the fractions to get there, but that would be my answer of that x is equal to 30. So that would mean 30 minutes to get 2.5 cups. Okay, that's one way of going about this. I want to also make sure you see that there's another way, because you might have, if I lost you along the way of trying to manipulate those fractions and doing the math. The other thing too is you could have just continued to double this until you get to something that makes more sense, right? So watch. If I know that 1/6 cup is 2 minutes, what's 2/6 cup? So I'm gonna do it up here. If I know that 1/6 cup is 2 minutes, 1/6 cup is 2 minutes, then what is 2/6 cup? I basically double it. How many minutes would, if 1/6 cup per 2 minutes, then 2/6 would be 4 minutes, right? Are you with me on this? And then what's true? 3/6 cup would be 6 minutes, right? I basically, if 1/6 is 2 minutes, 3/6 is 6 minutes if I multiplied by 3. And why did I do that? Because what is true about 3/6? So 3/6 is the same thing as 1/2. So now I know, what do I know? I know that from this information, I know that 1/6 cup takes 6 minutes. So if, excuse me, 1/2 cup.